good friends, welcome back. In today's session, we'll be talking about parallel circuits. Uh, Earlier this week, we talked about series circuits. We explained what series circuits were. Just to recap a little bit, series circuits are the circuit that have only one way for the current to flow. And parallel circuits will be the circuits that use more than one route to flow for the current. So the current has more than one route to go through. You see in this diagram here that I draw, you have a various route for the current to go from the batteries, the one battery, sorry. So it's going from here. It can find either route 1, which is going from R1, resistor 1, resistor 2, 3, 4, and 5, and finally back to the battery as negative terminal. So that's route 1. Route 2 will be, it's going from resistor 1, resistor 7, resistor 5, and we'll make the loop from here to here. So that is number 2, route 2. And route 3 will be from R1, R2, R6, it will go this way. R1, R2, come this, go back, R6, R7, and they'll go back to R5. So that is our R3, this is actually 7. So it'll go from R1, R2, it'll go to R6, R7, and R5, and back to the battery. And route 4 will be going, the current should go through, not should, it should, I mean, like it will also go through 1, R2, no, sorry, we'll go from R1, R6, because it will go this way, R1, R6, R3, R4, and finally back to R5, and then back to the battery terminal. So we'll complete the circuit. So we will have a various way for the current to flow, and that's how we say it's a parallel circuit, because it has parallel ways to go and complete that circuit. So where are we using these parallel circuit? That is, why is that so important? The parallel circuits are used in more vastly at homes, for the lighting system, for receptacles, for the power outlets. Because if we have series connection, for example, if one power outlet or some bulbs goes out, so it will disconnect the whole circuit of the house, so it will be not good. To put that example as here, like for if we have a 120 volts here, and we have a switch here, then we got another receptacle here, for example, and we have another receptacle here. Let's say they're closed switches, and you have the kitchen light here, for example. This is a light, and if any of these receptacle burns out, if that goes bad, you have no light here, because this will disconnect this current to flow from here, so you'll have no longer nothing coming to this terminal, so there'll be no power. Whereas if you have a parallel circuit, for example, and you have one right here, if the power goes off right here, for example, so this will be cut, but you still have power going to this point. This is your battery. So that's a benefit of having a parallel circuit, because the current will have another way of current to flow, for the current to flow. So that's why we use it at homes and other necessities that we don't have to rely on one or exactly one series circuit source. So I went ahead and draw the circuits for you here, the parallel in the series circuits. The example I said earlier should be, so we have 120 volts coming into, let's say we wire it up as a series circuit. It goes to the living room light. We got that light there, good. Now we have to go to the bedroom light. Okay, if there is a switch, you say, if there is also a small switch, if there is a selector switch or something, just push button switch. So you have 120 going in here. We got a light in the living room, a switch for the bedroom, and you have a kitchen light, and there should be a switch to SW2, and maybe a switch right here also, SW3. So let's say if somebody turn off the switch right here, so you have no light in the garage and you don't have light in kitchen. You wanted to turn off the kitchen light, but now you don't have light in the garage too, because your current, you discontinue it right here. You flip the switch to off position, so you have no light here. Since this light is getting a light, this garage light is getting power from the same route, so you flip that switch to off position. Now you have nothing going into the garage light. Or if somebody just turn off that switch because he or she is going to sleep, so she turn off the bedroom light. Now you have nothing in the, no light in the garage, no light in the kitchen also. So that's the downward of series connection of the house. So that's why we don't wire as a series connection for the house in the lighting system in the receptacles. So therefore we use these same lighting system in the parallel circuit. That will help better. Same 120 voltage going into the 4 emitters we have. We have a kitchen light, for example, which was the first. Okay, living room, we have bedroom, we have a garage light, and we have a kitchen light. If you have a switch right here for the kitchen, if you turn off your living room light, you still have a light in the bedroom, you still have light in the garage, you still have light in kitchen. So you have the current will still flow to the other places unless if you power off something, or unless you disconnect this battery, or if something is cut right here or defect before the going into circuit. Other than that, if you turn off the switch in your living room or a bedroom or garage or kitchen, any of these, you'll still have power to the other one, the one that switches are all still on. So if you burn light, or the whole power will not go off. So if you have a burn light here, for example, yes, this will not go off. You'll be still having a power, as I said, like, you have a route from here, you have a route this way, then you have a this way, and also you have a this way. So this will still complete the circuit, and you will not be out of electricity at your home. Okay, now talk about current in a parallel circuits. Total current in the parallel circuit is equal to the sum of current going through all branches. What is being said, total current, or IT, I total, current total, will be equal to the individual current going into all these branches. So say, like, the total current is equal to current in resistor 1, current plus current in resistor 2, resistor 3, and current in resistor 4. So these all are equal to your supply or total current. That should be equal to. Now voltage drop. So what is voltage drop in a parallel circuit? In the parallel circuits, all the branches have the same voltage drop, voltage as a supply voltage. So that means if you have for example, you have 12 volt DC power here, you have it, same thing is going this way. 12 volt DC is going this way, 12 volt DC is going this way, 12 volt DC is going That's way too. So you have the same voltage drop at each branches, each branch going into the load. So here they have the same. We got these three nodes. Nodes are the junction points of the connecting of the more than two wires. We have one wire going this way, one wire this way, one node too. Every node has the 12 volt DC going into it. So that's voltage stays the same right here, each branch going into. Now what is a total resistance? Total resistance in parallel circuit is not the same as the total resistance in series circuit, because since we said total voltage in a series circuit was not the same, because each resistor has a different voltage drop, and now here in a parallel circuit, the voltage drops, the voltage stays the same, current is different. In a series circuit we had current the same, voltage was different. The resistor has to find that resistor. We have three ways to find it actually. And something to remember here, total resistance in a parallel circuit is less than the smallest value of the resistor in the whole circuit. We will come to that point and prove it. How is that possible? So we will have in a circuit right here, in a parallel circuit, if we have a resistor here, resistor there, resistor there, resistor there. If you want to add all these resistors and want to find the total resistance, that will be the total resistance will be smallest than the smaller resistor among these, because it's a parallel circuit. Okay, so as I say, we have three ways to find the parallel circuit resistance here. The first one is easy one. If you have a same value, if you have same value resistors, 20 ohms, 20 ohms, 20 ohms, 20 ohms. So you will make sure like a total resistance to find it will be the value of the resistance, then divided by the number of the resistors you have. So that will be 20 is your value of the resistor, because you have to share the exact same value. And how many you have? 4. So that will be total will be 5 ohms. We said the total resistance will be smaller than the smallest resistor in the circuit. 5 ohm is the smaller than anything that you see here. For if you say like for example, we have one circuit right here. 1, 2, battery. So if that is 15 and this is 15, the total resistance will be 15 over 2 will be 7.5 ohm. So the value of the resistor and divided by how many resistor you have, 17.5 ohm. So the second method is the product over sum method. That's being said, if we have I use this method for having only 2 resistors, which is easy. But even if you have 3 or more than that, you can still solve the problem with that. But how you do it? You wanna multiply the resistance Rn times Rm. N and M are the real numbers here, and divided by same resistors, but you have to add it. Product over addition. So if you want to find the total resistance of these two circuits, for example, that will be this resistor times this resistor over this resistor plus that resistor. So we will solve this problem here. If we have 3 resistors in the circuit, we will have to, if you're using the product over sum method, that will be find the 2 first, then go to the third one, find the 2/3, draw the new circuit, and find the finals resistor there. To find this total resistance for there, we have to solve this circuit first. We will solve this one first. That will be resistor number 10 ohm, resistor number 1, 10 ohm, 10, 15 ohm, over 10 plus 15, it will be 150 divided by 25 will give me 6 ohm. Now this circuit, we draw the new circuit here, same VT right here, but instead of these two resistors, we draw the addition or the total resistance of that circuit. Now we have 6 ohm, and the third resistor is R3. So this is R1 plus R2. R3 is 20 ohm. So we will have the same exact way to find it. So 6 times 20, because this resistor product over 6 plus over 6 plus 20 will be 120 divided by 26 will give me 4.62 ohms. So we said earlier the total resistance in a parallel circuit is less than the lowest resistor the circuit has. So yes, so 6. If you check it, your value in the total circuit right here, 10 ohm, 15 ohm, 20 ohm. Your total resistance become 4.62, which is less than the lowest one, which is your 10. And that theory actually applies here too. Okay, are you guys ready for the third one and the fun one? The reciprocal method. Let's see. The reciprocal method is the general formula to find total resistance. The main formula for the total resistance is this one. No matter how many resistors you have, you can find it this way. There is a formula number 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on to 1 over Rn. N is your integer right here. So let me write this integer in the right way so I don't confuse you guys. Integer, it's a positive integer. We can't, because we don't have any negative resistance here. So this is one way to do it. The second way is RT. You just like flip it, then 1 over 1 plus R1 plus 1 plus 1 over R2 plus 1 over R3 and so on. I personally use this way to find total resistance, and once I find the value, then I reciprocate both the RT and the value. So it'll give me, I don't have to do the complex fractions here. For this one I do have to do, once I add these resistors, now I have to do complex. There'll be two ways to do it, but I prefer this one. You guys can choose that one too. It's as you guys like it. That's good. Whatever makes you guys happy, use that route. The problems or the formulas are confusing without example. Let's solve some questions using these formulas. Okay, example number, whatever number is that. In a parallel circuit, the following values are given as R1 is 50 ohm, R2 is 25 ohm, R3 is 120 ohm, and R4 is 15 ohm. Find the total resistance. Total resistor, that will be not right way to say it. Total resistance, and draw the circuit. Okay, let's use different color. Which color should I use? Green. Okay, so we are given, it didn't say what the power supply is, so we don't care about that. Let me draw the circuit first, so make it easy. Have 4 branches. We got 1, R2, R3, and R4. 1, 2, 3, and 4. R1, R2, R3, R4. It's R2 actually. So that is 50 ohm, 25 ohm, 120 ohm, and that is 15 ohm. So how we find the total value of the resistance here? Since we don't have any common resistors, we cannot do the type 1 formula. We said, like, you have to pick the common or the exact value over the number of resistor. We cannot use the number 1. We can use number 2, but there will be a little bit longer ways to do. But we will use 1 over RT, the general formula, 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. If you guys have any problem with the fractions, please go ahead and to my math tutorial. There will be operation on fractions there. You can watch those videos to help you with fractions, the addition and the subtraction, multiplication, and division of the fractions. Even I talked about the complex fraction there. So feel free to go there and watch that video too. That should be on my under the playlist of math tutoring. So here we'll talk about how to add these things right now. So 1 over RT equal to, what is R1? R1 is 1, just plug in that value. 1 over R1 is 1 over 50 plus 1 over R2, R2 is 25 plus 1 over R3, R3 is 120. R4 is 15, so 1 over 15. To find RT right now, 1 over RT. Find the least common divider here, LCD. So I believe 120 is not enough. To find LCD, you have to find a number that will be the smallest number, but it can be divided by it can be divided completely by 50, 25, 120, and 15. So let's see if we have this number here. 120 can be divided by 15. Yes. And 120 can be divided by 120, which is making sense. But 120 cannot be divided by 25 and 50. So we have to find out what numbers is we can have a least common divider there. Let's find it. Okay, so to find the least common divider, we will say, like, we have this number, write it down and start from the smallest number possible, 2. So you divide 50 by 2 will give you 25. 25 cannot be divided, just bring it down. Say 120 can be divided, so it will be 60, 15. So you carry on until you get all 1, 1, 1, 1 right here. So then if you multiply these numbers together, it should give you the value of your least common divider. So we got 600 as the least common divider. Now 600 divided by 50 will give me 12 plus 600 divided by 25 will give me 24. 24 times 1 is 24 plus 600 divided by 120 it will give me 5. So 600 divided by 120 is 5. 5 times 1 is 5. Now add it to 600 divided by 15. Divided by 15 will give me 40. 40 times 1 is 40. 40. Now add them together. 1 over RT is equal to 40 plus 5 plus 24 plus 12. Will give me 81 over 600. Now flip them both, reciprocate both of them, so it will give you RT equal to 600 divided by 81. 600 divided by 81 will give me 7.41 ohm. So that is my total resistance in this circuit. The total resistance is still smaller than the smallest value of the resistor in the circuit. Okay guys, let's find other values in parallel circuits. So far we only found the total resistance in this circuit. Now we will find if we have missing voltage, current, power. We will work on these, and let's go for it. Okay, so I said the Ohm's formula is your best friend here, because we will use it. We will use Ohm's formula and the power formula, which is I time P is equal to I time V, the current multiplied by the voltage, this one, and this formula will be our best friend. Let's do some example here. In a parallel circuit, some values are given. Find the missing values. 300 is resistor 1 is 300, 2 is 200, 3 is 600. Total current is giving 0.6 amp or 0.6 amp. Find the RT, V1, V2, V3, P1, P2, P3, and PT, and also VT. We have quite a few missing numbers here, so let's go ahead. It didn't ask for us to draw the circuit, but we will draw it anyway to make it simpler. So let's draw it on this side. Let's reuse different color right now. For the circuit, use the blue one. Power going in, we have a 1R, 2R, R2, R3, R4. So this is R1 is a 300 ohm, R2 is 200 ohm, R3 is 600 ohm. We don't have R4 actually. It's a good thing we have R3 only. We'll cut down the circuit right here. So it's been asked to find the VT. IT is given 0.6 amp. PT, RT. Find V1, V2, V3, I1. It actually didn't ask for I1, so we will not worry about that. Okay. So find RT first, because that seems to be easy. Use white color for that. So if we use the Gen 1 formula, 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, let's plug in those values. 1 over R1, 1 over 300 plus 1 over R2 is 200 plus 1 over R3 is 600. Okay, as usual, find the common divider for that. Will be 600, because it can be divided by 200, 300, and 600. 600 divided by 300 will be 2. 2 times 1 will be 2. Plus 600 divided by 200 will be 3. 3 times 1 is 3. Plus 600 divided by 6 is 600 divided by 600 will give us 1. 1 times 1 will be 1. So 2 plus 3 plus 1 will give us 6 over 600. We can simplify it here, but let's reciprocate this one first. It will be 1 over RT will become R total, 600 over 6. So this will give us 100 ohm. RT is 100 ohm now. Now the second thing is being asked, find the total voltage, VT. We can use the Ohm's formula, is I time R, or IT time RT. IT is given 0.6 amp, time RT we just found was 100 ohm. 100 times 0.6 will give me 60 volt. So VT is 60 volt. Now, so we found this one, VT. Where is my VT? 60 volt. Now we can use the power formula to find the PT. PT is equal to VT times IT. So VT total voltage we found was 60 volt. 60 volt times 0.6 will give me 36 watt. So we found the PT also, total power. We found the VT also. Now we will find individual voltage. And remember this thing, we said, like, remember that? Remember, in a parallel circuit, total voltage is equal to voltage drop at 0.1, voltage drop at 0.2, voltage drop at 0.3. So we have all these are the same voltage right here. So that being said, now we can find the P1 and P2 and P3. So P1 will be equal to I1 times V1. We know V1 already, but we don't know I1 because current is not the same in a parallel circuit. It has a different values. So let's find I1 first. I1 will be equal, using the Ohm's law right here. So it'll be equal to V1 over R1. V1 is what is it, 100? Now V1 is 60 volt divided by 300 will give me 0.2 amp. So I1 is 0.2 amp. This is 60 volt. This is 60 volt. This is 60. Volt. That look like 80. Okay, so now we can use this for P1 formula to find the power and resistor 1. It will give us I1 is 0.2 and V1 is 60 volt. So that will give me 12 watt. P1 is 12 watts. Now let's find P2. Before we do find P2, we have to find I2 also. I2 is equal to V2 over R2. V2 is 60 volt and R2 is 300. R2 is 200. $60 divided by 200 will give me 0.3 amp. So I2 is 0.3 amp. Now we can use the P2 formula to find the total power, and resistor number 2 will give us a 0.3 times 60. That will be 18 watts. Finally, to find P3, we will follow the same procedure. It will be I3. P3 is equal to I3 times V3, or current and resistor number 3 times the voltage in resistor number 3. We don't have current in resistor number 3. We will have to find it. I3 will be equal to V3 over R3. V3 we know is 60. R3 we know is 600. So this will cancel out. It will be 0.1 amp. So there will be 0.1 amp. Now we can plug in this value in this formula. 0.1 amp times 60 volt. It will give me 6 watt. So we have our values. We found VT, total voltage, was 60 volts, and this is equal to V1, V2, and V3. PT is equal to total power in the circuit is equal to, we said, what was the total power? We just found it right here, 36 watt. 36 watts. Remember, the total power should be equal to the sum of the individual power. Let's find out. P1 is equal to 18 watts. P2 is equal to P1 is equal to 12 watts. P2 is equal to 18 watts. P3 is equal to 6 watts. If you add them all together, it will give you 36. These will give you PT 36 watts. Okay, hopefully this was not a hard example to do. Please, it requires a lot of practice. Go ahead and solve this example again and do a little bit of practice. It will help you. So are we ready for the next example?
No, God! No, God, please, no!
In a parallel circuit, find the values of missing components. Resistor 1 is 800 ohms, resistor 2 is 1600 ohm, resistor 3 is 300 ohm. What is R3? Resistor 3. But the current going through R3 is I3 is 0.4 amp. Find the following values: V1, V2, V3, VT. R3 is also missing, I1 is missing, I2 is missing, IT is missing, I3 is given right here, P1, P2, P3, and PT. So just to make our life easier, let's draw this circuit first. Let's do it in a blue color. We have a battery connected here. Go up. We have how many resistors? We have 3 resistors. 1, 2, 3. So R1 is 800 ohms, R2 is 1600 ohms, R3 is unknown, and I3 is 0.4 amp. And find the missing value. So RT is given as a 300 ohms. RT is 300 ohms. We had a formula that to find RT, we could do that 1 over RT equal to 1 over R1 plus 1 over R2 plus 1 over R3. RT is 1 over 300. RT is 300 ohm, but 1 over RT will be 1 over 300. 1 over 800 ohm here. It's R1 1 over 1600 plus 1 over R3. So we will leave 1 over R3 on the right side and move these values to other side. It will be 1 over 300 minus 1 over 800 minus 1 over 1600. So the LCD for this one will be the LCD will be 4800. So let's solve that thing. 1 over R3 is equal to 4800. 4800 divided by 300 will give me 16. 4800 divided by 800 will give me 6. 4800 divided by 1600 will give me 3. So 1 over R3 is equal to 16 minus 9 will give me 7 over 4800. And find R3, reciprocate both of them, reciprocate both sides, will be R3 over 1, 4800 over 7. 4800 divided by 7 will give me 685.7 ohm. So that is my R3 right there. R3. Now to find the VT is equal to IT time RT. And that will be, since we don't have IT there, we gotta find IT now. We do have V3, we have R3 and we have I3. We can find V3 there. V3, let's do this. It will be I3 time R3. R3 is 685.7 ohm time 0.4 amp. Let's see what we have. 685.7 time 0.4. 685.7 time 0.4 will give me 274.3 volts. Let's write this one down back. Will give me 274.3 volt. And we said in series circuit the voltage drop stays the same all over the place, so we can find the current in other branches right now. In parallel circuits, voltage are the same across all the branches. So we have 274 here. We should have 274 here too. We should have 274 right there also. So we have these 3 branches that should have the same voltage drop there. Let's go ahead and find now, since we have R2 and V2, let's find I2. I2 will be V2 over R2. V2 is 274.3 divided by R2 is 1600. It'll give me 0.17. So I2 will be equal to 0.171 amp. Let's do the same thing with the, since we have R3 and we already did R3. Since we have a R1 and V1, let's find I1. It will be V1 over R1. V1 is same thing with 274.3 divided by R1 is 800 ohms. Yes, 800 ohms. This is volt. So 274.3 divided by 800 will give me 0.343 amp. So what is our IT or total current? Total current is always, we can find it two ways and then compare it. IT will be equal to IT will be equal to VT over RT. VT is 274.3 divided by RT is 300 ohms. 274.3 divided by 300 will give me 0.914 amp. Now to find out I1 plus I2 plus I3 should equal to IT. To do the math right, let's find out what is I1. We found I1 was, we already find I1, which is 0.343 amp. I2 is 0.17 amp. We did not find R3 actually. Let's find I3 right here. Okay, so I3 will be equal to V3 over R3. V3 is 274.3 divided by 685.7 will give me 274.3 divided by 685.7. That will give me 0.4 amp. Now to find out if IT total current is equal to these individual currents, the sum of these individual currents, let's find out. 0.4 plus 0.17 plus 0.343 will give me 0.913. So yes, we are close to each other. That should be fine. Moving on to the next section, which will be finding P1, P2 and P3. Let's go on, find that P1 and P2, P3 also. We can find P1 as V1 times I1. P2 will be V2 times I2. P3 will be V3 times I3. And PT total power will be P1 plus P2 plus P3 or VT times IT. You can do that. So we know we have a V1 is equal to 274.3 times I1 is 0.343, and that will give me 0.343 times 274.3, 0.08 watts. P2 will give me 274.3 time, what is I2? I2 is right here, 274.3 times 0.17 will give me 46 watts. 46.6 watts. And what will be the P3? Will be the same voltage, 273.3 times I3 is 0.4 amp. It will give me 274 times 4 will give me 109.72. 274.3 times 0.04 will give me 109.72 watts. If I add them together, 46.6 plus 94.08 will give me 250.4 watts. Now if I do it this way, VT total voltage was 274.3 times, and IT we just found it, IT was 0.914. If I do it this way, 0.914 times 274.3 will give me 250.7. So that's relatively close to this one. The error will be the rounding error, still same thing. So we can, once we find the individual one, we can find it individually, like the way I did it here, like here, individual one, or you can just find it straight, the PT, because since we have VT total voltage and total current, we can find the power of that circuit too. Hopefully this example was not bad. Let's move on to the next example. The example is in a parallel circuit, the power going through R1 is 0.0775 watts, power through R2 is 0.45 watts, power through R3 is 0.225 watts, and the total current is given as 0.05 amp. Find the following: V1, V2, V3, VT, total voltage, I1, I2, I3, R1, R2, R3, and RT. Okay, so this is kind of tricky. Okay, so these are the values that are given, and these are the value they are asked. This circuit is a little bit challenging because only power is given, and we don't have anything other than amperage of the total current. But we can find the we will draw the circuit later, but we can find the PT in a way, because we only have three sources of power and three places that power goes through, which is R1, R2, R3, and the powers are given in each point. So P1 plus P2 plus P3 will be equal to PT. So now let's add them together and see what we get. 0.075 plus 0.45 plus 0.225 will give me 0.7V5 watts. Okay, so we have a formula for that. The power formula is P is equal to I times V. To find V, so we have for example, VT will be PT divided by IT. So PT is total power is 0.75 divided by 0.05 will give me 15 volt. So 15 volt is our total voltage. Now in a parallel circuit, voltage drop at R1 is equal to voltage drop in going into R2 and also in R3, and that will be equal to Vt, so that's 15 volt. Now the other things asked, so these are, we found it as 15 volt. Now we will find R1 actually here. So we found the V1, we will find R1, R2, R3, RT. To do that will be a little bit tricky. We have to use power formula, then we will use the Ohm's law too. So the power formula, P1 will be equal to I1 times V1. Since we cannot find resistance from here, we will have to modify that. And from Ohm's law, we have I1 is equal to V1 over R1. Because V1 is given, we will substitute this one in here. So P1 will be equal to I1 will be V1 over R1 times V1. We will plug in the value that we have. P1 is 0.075. V1 times V1 will be V1 squared over R1. So to find R1 will be V1 squared over 0.075. So what we did, we swapped these numbers. It's a mathematical method there. These two multiply together, these two multiply together. When you multiply these together, so that will give me R1 times 0.075 equal to V1 square. Now multiply both sides by 0.075, and that's how we ended up right here. 0.075, 0.075. These will cancel out, so R1 will be equal to V1 squared 0.075. So that's how we ended up here. Side note, okay, V1 squared, what is V1? We found V1 is 15 squared will be 225 225 divided by 0.075. 0.075 will give me 3000 ohms. Now let's try the same exact method with R2. R2 will be equal to V2 squared over P2, and that will give me 225 divided by 0.45. That will give me 500. Okay, let's write it down. That's 15 squared divided by 0.45 will be 225 divided by 0.45. R2 will be equal to 500 ohm. Now let's find R3 the exact same way we did the R2 and R1. Will be R3 will be equal to V2 squared or V3 squared over V3. V3 is the same, 15 squared. P3 is 0.225. Will be 225 divided by 0.225 will give me 1000 ohm. So R3 is 1000 ohms. Now the final thing to find out will be the RT. Let's find RT and then we'll draw the circuit. RT will be, we have the general formula, we can use it. 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Plug in the values here. 1 over RT, 1 over R1 was 1 over 3000 ohm, plus R2 is 1 over 500. R2 is 500, but the second term is 1 over 500. The third term, which is 1 over R3, will be 1 over 1000. After finding LCD, okay, so 1 over RT will be the LCD will become 3000 here, because 3000 can be divided by all these numbers. 3000 divided by 3000 will be 1. 1 times 1 is 1, plus 3000 divided by 500 will be 6. 3000 divided by 500 will be 6. 6 times 1 will be 6, plus 3000 divided by 1000 will be 3. 3 times 1 will be 3. So this will become 1 over RT will become 10 over 3000. 10 over 3000. We can cancel 1 0 right here. So RT will be equal to 300 ohms. Okay, so we find all the values here. Let's draw the circuit with the green color. We have 3 resistors. We have a battery, resistor 1, resistor 2, resistor number 3. So this is the circuit right here. It's 15 volt DC. PT is, did we find PT actually? Yes, we did. Maybe we did. Yes, we did find it. It's 0.75 watts. 0.75 watts. And IT was, what did we find? IT was 0.05 amp. And the other values are right here. We find R1, R2, R3, total resistance, and all the way to the total power and everything. R1 is 300 ohms, R2 is 500 ohms, R3 is 1000 ohms. Alrighty, I hope this example give you some light up, and you guys can go ahead and solve it again, or try it again, or try a different example to use this as an example and try to find the values of another missing components. Let's move on to the next example. The next example says find the missing values. So we see like I1 is given, I2 is given, I3 is given, and I4 is given, and total voltage is given, and nothing else is given here. So we will have to find R1, R2, R3, R4, and RT also, P1, P2, P3, and P4, and also total power. Since we have a I, we can find IT will be equal, because total current will be the sum of all the individual current will be I1 plus I2 plus I3 plus I4. So that will give us the value of I1 is 0.176 plus 0.12 plus 0.255 plus 0.364. Let's add them together and see what we get. 176 plus 0.12 plus 55 plus 364 will give me 0.915. amps. So since we have IT equal to 0.9, 0.9, 0.915 amp. Now using that, and we have VT also, we can find RT. RT will be equal to VT over IT. Total voltage is given 15 divided by 0.915 amp. Okay, so 15 divided by 0.915 will give me 16.39, which are rounded up 16.4 ohm is equal to RT. Okay, now we will find we got this one will be 16.4 ohm. We'll find R1. R1 is equal to, will be R1 will be equal to V1 over I1. V1 is given as a 15 volts divided by I1 is 0.176. That will give me 15 divided by 0.176 will give me 85. That will give me 85.2 ohm. R2 will be V2, since the voltage is same here, and here, and I's are, the current is given in every resistor, so we can use that. R2 will be V2 or I2, which is 0.12. It will be 15 divided by 0.12, give me 125 ohms. Let me write down the values first before we get confused. That will be 15 divided by 0.12, and that will give me 125 ohms. Now R3 and R4, we will find it as follow. R3 is equal to V3 over I3. This is I2 actually. And that's 15 divided by I3 is 0.225. 15 divided by 0.225 will give me 66.7 ohm. And R4 is equal to V3 or V4. Let's do something. Let's clean this thing up. This was I2. R4 is equal to V4 over I4. V4 is same as V1, V2, V3, and I4 is 0.36. 15 divided by 0.36 will give me 41 ohms. 41.67 ohms. So RT, you guys find RT using this formula. 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. And tell me if your answer matches with this, which will still give you 16.4 ohms or not. Now we have 4 missing components. We will find it. We have a P1, P2, P3, P4, and PT. So let's find P1, P2, and P3. P1 will be equal to I1 time V1. We found I1 was 0.176 and V1 is 15. So 0.176 times 15 will give me 2.64 watts. P2 will be I2 times V2. I2 will be 0.12 times 15. 0.12 times 15 will give me 1.8 watts. Unit of power is watt. P3 is equal to I3 times V3. I3 is 0.225 times 15. 0.225 times 15 give me 3.375 watts. And P4 will give me I4 times V4. I4 is 0.364 times 15. 0.364 times 15 will give me 5.46 watts. We can find PT by adding them, these P1, P2, P3, P4. P1, P2, P3 plus P4. We can add them and see what we get. 3.375 times plus 0.18 plus 2.64. So to add these numbers will give me 13.275 watts. So that is my PT, or total power, or we can find it as a PT is equal to IT times VT. Total current we found was, what was the total current here? IT was 0.915 times 15. 0.915 times 15 will give me 13.72. 13.725 watts. That will be my PT in this way. 13.725. Okay, we have a very last example to solve it. Don't get bored, guys. It requires some practice. Please do practice how to solve the circuits. Let's move on to the next example. Hope you guys are ready. Are you guys ready?
Nay.
Okay, very final example. Find the missing values of the circuit below. Total voltage is given. I1, I2, I3, I4 are given. And now we have to find let's get the green because it's the final example. IT, we can find IT here because I1, all the current is given in the circuit. I1 plus I2 plus I3 plus I4. And that will be 63 plus 84 plus 16 plus 22. So that will give me 63 plus 84 plus 16 plus 22, 185 amps. This circuit is drawing 185 amps. That's a huge circuit. Now since we have VT and IT, now we can find RT. total resistance will be Vt over It. Vt is 480 divided by 185. 480 divided by 185 will give me 2.594 ohms. So that is my RT. Now we'll have to find R1 actually. R1 will be equal to V1 over I1. We know V1, V is here, the same thing, 480 here, 480 here, 480 here, 480 here. So V1 is 480 divided by 63. That will give me 7.619 ohm. R2 will be V2 over I2. V2 is 480. I2 is 84. 480 over 84 will give me 5.714 ohm. R3 will be V3 over I3. V3 is 480 divided by I3 is 16. 480 divided by 16 will give me 30. And R4 will be V4 over I4, and that will give me 480 volts divided by 22 amp. 480 volts divided by 22 amp give me 21.818 ohms. So that's my total, that's my individual resistance here. To find the total resistance, we can, guys, that will be for you guys again, find RT. Find it using one over RT equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. And see, then compare that with my RT, which I found 2.594 ohm, if that's actually close enough what you guys find. Moving on, we will find the P1. Post your answer in the comment, please. What do you find for RT for this example? P1 will be V1 times I1. V1 is 480. I1 is 63. So 480 times 63. 480 times 60. 480 times 63 will give me 30,240 watts. P2 will be V2 times I2 be 480 times 84. 480 times 84 will give me 40,320 watts. P3 will be equal to V3 times I3, and that will be 480 times 16. 480 times 16 will give me 7,680 watts. And P4 will be equal to V4 times I4, That will be equal to 480 volts time 22 amp, and that will give me 480 time 22 will give me 10,560 watts. It's been asked to find the PT also. PT is, you can find it as added P1 plus P2 plus P3 plus P4. We say like, because the theory is that the total power in the circuit should be equal to the individual power going in the circuit, and summation of all these power going back to the coming in, the total power coming into the circuit should be equal to the whole power or individual power of the whole circuit. So let's add, if you add them together, see what you guys get. But I will find the value of PT like that, VT time IT. VT is 480 volts time, what is IT? IT I found 185 amp. 480 times 185, I get 88,800 amp watts. See, that's a PT 88,800 watts. That's what I got for the total power. Now if we add these together, let's do some basic math. 30,000, 40,000 and 10,000, that's 80,000 there, and 7,000, so 87, and you got some change, so probably ending up like with 88,000. Let's check the math here. Let's add them together. 30,000 240 plus 40,000 320 plus 7,680 plus 10,560. I got 88,800. 88,800 even. Wow, look at that, it matched the answer. No rounding errors this time. So this was it. We found everything we were asked to. So this was a circuit given. We find R1, P1, R2, P2, and the total voltage here, and total power also altogether. This was it from the parallel circuit, guys. I hope you guys get something from this video, this lecture. I will see you next time in the electrical classes with the combination circuits. Until then, guys, take care, and please don't forget to subscribe this channel for more useful videos. Don't stress it out, just practice, and that will be easy for you next time. Thank you, guys.